Welcome, everybody. I'm Michelle McLean. I'm the VP of Marketing at Salt Security. Really excited to be with you guys today. And I'm joined by Michael Isbitsky, our technical evangelist. Michael, here at the top, let's just take a minute for you to share a little bit about your background. I think it's helpful for people to understand what has shaped your perspective.
Yeah, absolutely. Thanks, Michelle. So prior to joining SALT, I was actually a Gartner analyst covering specifically application security. But also API security and a lot of the things that kind of tie in with that, certainly DevOps and DevSecOps initiatives, but helping organizations of all sizes and across verticals, secure apps throughout the SDLC, certainly build pipeline testing, but also a lot of runtime security, right? Like how do I architect my networks and system designs to be resistant to attack. I spent about 5 years doing that. And prior to that, I spent about 20 years as a practitioner doing a lot of systems engineering for Verizon. And then towards the latter years there, I actually led their application security program internally. So a lot of mobile app testing, web app testing, and of course, APIs.
So you have lived a lot of this stuff. Awesome.
Oh, yeah.
Thank you so much, Michael. So, what's going on? What's happening in the environment these days? We're seeing a lot of news about API attacks. If you think about just even the last few weeks, in very quick succession, we had incidents at Experian, Peloton, and Echelon. It's just like one after another. We're seeing these, and this follows a lot of other large-scale attacks that, or leaky APIs that folks like Facebook and people are suffering. And there's a lot of kind of misconceptions out there. We actually have a whole bunch of content just around API Mythbusters, which we welcome you to check out. But, kind of why are we seeing this constant stream of API-based attacks? Well, the reality is they're just so darn attractive, right? I kind of think of API as like the ramp agents at the airport, right? With the orange batons. APIs are directing people straight to your most precious data and services. And attackers know this. So it's very lucrative to go after APIs. They've really figured this out. But it's interesting to think about, how do they get in? How do they find their way? I feel like a lot of people building APIs think that they're safe because they're kind of resting on the security through obscurity principle, right? Well, we're the only ones who know how our API is written. We're the only ones who know how it works. And they're kind of hoping it's that monolith in the desert, right? Nobody's going to know what this is. Nobody's going to know how our APIs work. So they're not going to be able to attack them. Reality is security through obscurity has never worked. It's not going to work for APIs. And so today what we're going to talk through is some of the mechanisms that attackers use to find your APIs. The tools that they use to kind of reverse engineer and understand the business logic of your APIs, and then how do they do any of this at scale, right? How do they automate to make this a more practical endeavor? So, Michael, why don't we have you kick us off by taking us through a little bit about how attackers find APIs in the first place?
Yep, absolutely. Thanks for that intro, Michelle. Yeah, it's interesting, right? Even as a practitioner, what I was trying to explain, how did I even begin the steps to inspect an app, right, and see traffic? Often it's kind of viewed as this black box, and certainly in the world of mobile applications, right? Like it's kind of, I don't know, it's almost like human perception that like here's the app and it exists on my Android device or iOS device, and you can't really get into that and see what's going on. The reality is something much different, right? We're going to kind of step through that today, like what's kind of the typical sequence of how attackers find things, and then start probing and extracting information and exploiting weaknesses in the underlying design. So reconnaissance techniques, right? If you're coming from the world of security as opposed to development, hopefully we have everybody from different walks of life here today, but if you are kind of coming up the ranks from security, you've likely heard about reconnaissance phases of, attack chains or attack methodologies. It's really just kind of, you're trying to gain as much information about the target as possible. Hopefully you're doing that passively, right? You really don't want to tip off the attack target of what you're doing. So, a lot of detection techniques, and we're going to talk about a little bit about this later. That's kind of how we've built the SALT platform. But attackers are stealthy, right? And if you've ever used a tool like Nmap, which is essentially a port scanner, it's very capable, right? It's been around for a long time, but there's options you can give it to make it run stealthily, right? So maybe scan sets of ports very slowly over time to not tip off network detection mechanisms. But attackers are also, craftier than that. They're going to certainly harness everything they can, with the power of the internet. Google dorking or Google hacking has been around for a very long time, right? It's kind of just harness all that information that's already at your fingertips. It's actually incredibly useful for somebody that's trying to assess an organization. But also like SEC filings, right, and patent filings. A lot of organizations don't realize that information is publicly accessible, right? That's by design. We're U.S. citizens. Companies agree to do business. These things are public information, so that becomes a rich source of information. But these are traditional techniques. What we've seen is that this has expanded, right? Attackers actually have a lot more tools at their disposal and information sources. Shodan is really popular these days, right? It's kind of, I don't need to run Nmap necessarily because something like Shodan's already kind of scouring the internet. And Rapid7 also was doing this. They've kind of open sourced that information as part of Project Sonar, but they're these, giant repositories of scan data of everything on the internet. So you can very, very quickly assess, like who's running a vulnerable, Apache server, who's not blocking certain headers that are exploitable. So it's, a tool of the trade. Social media platforms too, right? We actually, unfortunately, volunteer a lot more information about ourselves, but also the organizations we work for when we go on to social media platforms, right? And it's not going down the weeds of is social media right or wrong, but it's the reality, right? There's typically a lot of sensitive and private data there that attackers will use. Git repo hunting too. Git it's certainly a source code repository, but it's really just a version control system. You can store anything there, including documents, configuration information, everything, data sets, right? So, Git repo harvesting, as well as S3 buckets. They're almost interchangeable, right? S3 is like a little bit more multi-purpose storage, so you can, it's cloud elastic storage. Git gives you that version control, but a lot of organizations and developers are storing things there that contain highly sensitive data. And then we talked about the mobile app scenario, right? Like those mobile apps exist in public app stores. That's by design. The Google Play Store and Apple App Store. Those apps you can download and then start extracting the binaries. We're going to talk about that in a little bit. And once you install it on device, it's kind of open season, right? You can inspect everything that app does and how it communicates. I just wanted to take a minute too to talk about methodologies, because I'd say this is very commonplace in security industry as well, where we almost get hung up on attacker methodologies and attack chains. There's a lot of them. I'm not going to kind of boil the ocean and rattle them all off, but this is actually kind of derived from the certified ethical hacker pen test methodology, but there's many, right? There's MITRE ATT&CK framework for kind of cataloging how somebody's attacked your systems and coordinating incident response. The reality is attackers, they're going to use things to organize themselves, but they don't necessarily care about these defined sequences, right? And it drives security teams a little nuts, right? Because it's your systems might be built to kind of catalog this way, and an attacker's not going to work that way, right? And in the case of APIs, persistence isn't necessarily a desired state, right? You might want something that's reproducible, but you're not necessarily going to try to own the system, right, and get root access. That's maybe more like workload compromises and attacking infrastructure. So in the world of APIs, it's much more about, I just want to find an API that's weak or leaky, and then start probing that thing and extracting data. So, attackers, they're not sequential, right? And they'll jump around, right? So they might start doing reconnaissance, and then very quickly just start enumerating your APIs and extracting data. They're not necessarily tracks to cover, right? Like that could depend on how well you're doing logging in your back ends, but typically API calls are they're very high rate of frequency that your consumers or employees are hitting those things. So it might look very innocent. So they don't even necessarily need to cover tracks. The API is doing exactly what it was intended to do. So yeah, methodologies are kind of tricky, and actually we've seen this too in the recent Verizon data breach investigation report, where they had to create a new system intrusion pattern because attack chains are actually much more complex now, right? They're not so simple like this, where there's 5 steps, right? They're going to jump around. They'll use different techniques like ransomware, mage carts, credential stuffing is very common as well. So yeah, this is becoming much more commonplace. So it's a little bit of a shift from kind of traditional security thinking and training, from the past 10 or 20 years.
Makes sense. And I think the key takeaway that you're really getting at here, Michael, is that they're not going to play by the rules. Yep. It doesn't matter if you kind of have a process and a flow that you're hoping things will go through. They're not going to follow them. And I think the second point that I'm really hearing you say is, assume the breach, right? This is one of the fundamental premises of security is, do everything you can, but then assume the breach. So we should assume hackers are figuring out part of our code. So, let's say they've gotten some form of a foothold, some knowledge about what's going on, kind of walk us through, how do they go about exploiting that, and what do they do now that they have some inkling about what our APIs do?
Yeah, absolutely. So let's kind of talk about like how does an attacker reverse engineer, right? So I've done that reconnaissance. I discovered some host information about the organization I want to target. Maybe that even started with some basic domain name querying, and then I've gone from there. And now I found some API endpoints, but more likely I found some websites and mobile apps that I want to start to pick apart. So let's talk about some tools of the trade. If you are coming from this world of application security, you may be familiar with these, and actually even as a developer, particularly like the debugging focused or troubleshooting focused intercepting proxy tools. These are very common for exposing the inner workings of how applications communicate over the web. Typically that's HTTP or HTTPS, but they expose those communications. In the case of debugging, that's really useful for understanding, well, did I design my website or mobile app to be performant? Are things working as expected? Because I might want to tune that. Maybe I have too many script calls, or offsite script includes. Like all of those things kind of contribute to the performance and user experience. So very common to run something like Fiddler or Charles Proxy. As a security practitioner, Port Swigger Burp Suite, very common. It's actually very cheap as well. But even if you don't want to spend a few hundred for the Burp Suite license, OWASP Z-Attack Proxy is also very capable and common. A lot of organizations actually take ZAP and automate that as a dynamic application security testing tool in their build pipelines if they don't want to pay for a heavier weight commercial tool. But these are really common, and we actually have some screenshots of how you can expose the communications. So we'll pick that apart a little bit, but just understand that everything that a web app or mobile app does is visible. It is not a black box by any measure. The other that's becoming really common with APIs is something like Postman. And Postman is really great, API design and testing and mocking tool. You can share, API definitions within it as you're, crafting APIs and developing things. And actually, you're going to see in the video how one of our engineers, scripted attacks through Postman. So it's a developer tool, but also an attack tool. And that's kind of a common thread, right? Like the things that developers might use are also things that security teams might use, but also attackers, right? So it's kind of, you can't necessarily ban the tool, right, or view it in a negative light. It's much more about the intent. How is somebody using these things? IDEs are also definitely a tool of the trade, right? Because I can, as we're going to see in a bit, I can kind of pick apart the code or reverse engineer it. Front ends are easily decompiled or disassembled. And Android APKs that you pull from the mobile app stores or iOS IPAs, you can get, particularly in the case of Android, you can get something very close to original source code back, right? And start understanding how did the developer build this application. You're certainly going to see API calls and code, but you also see that through the traffic inspection with the intercepting proxy tools. And those decompilers I was talking about, there's quite a few, particularly in the Android space. Typically what happens is it's true of security practitioners, but also attackers. They'll start in Android. It's a very, very popular mobile operating system, very large ecosystem. But the design Android, because it is Java-like, Java is an interpreted language. The code has to compile to like an intermediate format. By virtue of that, it's actually more easily reversed, right? So you can get something back to original source code that's actually pretty readable. Apple apps with iOS, it's a little bit of more of a learning curve. That's why it might be something that a practitioner advances to or an attacker. And you still have, the world of x86 and ARM. So like traditional Windows binaries or Apple binaries, where you might have something like IDA Pro and you're looking at something that's basically assembly. But these are tools of the trade, right? This is what attackers are using to pick apart your client apps and then understand, well, how do they talk to the backend components? Because that's likely the thing of value. And then I'm going to start targeting those backend APIs directly. All right, so let's take a look very quickly at some screenshots of something like Portswigger Burp Suite. If you haven't taken a look at the tool, I'd certainly encourage you to download the Community Edition or OWASP Zap. You can start intercepting, everything you do on your machine. You can also do it on your mobile device. In this case, I captured the screenshots, but I captured my session just logging into Google, one of the G Suite services. But you always get challenged with, the Google SSO mechanism, right? You have to authenticate. Well, what does that look like, right? The user experience is this, right? I'm just plugging in my email, and in this case, I was using a dummy password. But behind the scenes, I'm actually seeing, well, what is actually being sent to the back end, right? And as an attacker, this is incredibly valuable, right? Because now I know, well, what does the format of a request need to look like, right? If I was just taking something like, the Shodan data or Project Sonar, I might know there's a host, maybe there's an API, but I might not know how to interact with that. So that's why it becomes incredibly useful to have like these clients that interface with backend APIs, because now you can start to pick apart, well, how do you work with those backend APIs, right? Because REST APIs they're not standardized, right? It's a style, not a standard. So they can look very different from one organization to the next on how you work with them. So having that front end client application is a huge benefit to, well, certainly the security practitioner trying to do testing, but definitely the attacker, right? Because now they can see, well, this is how the API call should work, right? And then I'm going to observe, well, I entered a bad password, so what does the server response look like? And maybe it doesn't respond well. Maybe it's not checking certain things, right? And then I can start pivoting from there. And this is typically how every attacker starts, right? They're going to, and this is passive reconnaissance. You would never detect this in the back end. I am essentially functioning as a user. I'm looking at my own traffic and just trying to understand how the application works. So this isn't malicious, right? This is entirely passive analysis. And there was no issue with Google here, just kind of an example of what this login sequence looks like, and just kind of the visibility you have over how these authentication sequences work.
Yeah, it seems like what you're highlighting is, what you think as a developer might be kind of obscure is actually not that hard to reveal. And that, just touching back again on motivation, this is the beginning phases. Like, I think this is one of the most important things to understand about API attackers and attacks is just the number of steps it's going to take. It is a lot of steps, and it's not you learn one thing and you get the treasure trove, right? It's a lot of steps put together. But just seeing the beginning of how they begin to understand what's happening at the code level, it's so helpful.
Yep. Yeah, and it's very true, right? So the setup of this, very simple, right? You could do this in a matter of minutes once you're kind of skilled with it. But yeah, it absolutely takes time to kind of fingerprint how things work, reverse engineer. And we've seen that, we saw that in the Parler attacks where that researcher was spending quite a bit of time kind of understanding how the iOS app worked. And then they worked backward from there, right? And started to attack the APIs directly. Created scripts that allowed you to create dummy accounts, scraped APIs, at large scale, and then distributed that, right? That's how they were able to extract everything from that platform. But these are the beginnings of it, right? This is how it works. This is how security testers actually work. So if anybody is in the application security space, I'm probably telling you things you already know. But for everybody else, this is how simple it is. And if you notice there, it does say HTTPS. One of the questions I would usually get, particularly when I was doing the AppSec work and talking to development teams, was, well, how do you even see that, right? Because this is supposed to be encrypted. I'm using, well, in those days it might have been SSL. It was kind of at the tail end, but more so TLS, right? You should be using TLS 1.2 or better now. Why are you even seeing this? Well, the reality is you can always terminate TLS sessions, right? So what's happening when anybody installs these kind of client-side intercepting proxies is they're terminating that TLS session, right? I'm not necessarily intercepting, right? I'm not doing anything that violates the protocols. I'm terminating, so I can view the traffic, and then I re-encrypt, right? So it's maintaining a TLS session. It's just I've now inserted myself kind of in that network communication stack, and now I can see all the encrypted traffic, right? So this is why we often tell organizations like TLS is not API security, right? It's encrypted transport, and there's a lot of ways you can expose that traffic. We were showing here like how I might do it as an attacker or a security tester with device level proxies and explicitly trusting the certificates of the intercepting proxy. Normally you wouldn't do that, right? That could be potentially malicious, although some users fall for that, right? That's actually some things we see with ransomware and other forms of phishing attacks. But attackers target TLS. That's not uncommon, right? So that's why it's a very low bar. Yes, you should do it. A lot of compliance and regulation mandates that you need to do it, but acknowledge that it's really just protecting that network communication, but also only minimally, right? There's ways to kind of terminate that session and view the traffic. I've listed some of them here. I'd say these are probably the more common ones that attackers will use. Some of them are network-based attacks, right? Like standing up rogue Wi-Fi hotspots. More recently, we've seen advanced attacks where somebody intercepts cellular communications. But sometimes it's not even that advanced, right? Like maybe the organization just didn't turn on the right version of TLS, right? Or they have weak ciphers enabled. And then there's known exploits against those versions of SSL or TLS. So it's really a very low bar. It buys you very little in regards to API security specifically. The screenshot here is actually where I pushed the Portswigger Burp Suite certificates to my own Android device so I could proxy that session like you saw on the other screens.
Yeah, I think it's great to have these little wake-up calls, right? Of I think I'm safe because, and I I think encryption is one of those things. You know, and then I think the other one where we see this a lot is around API gateways and WAFs. A huge misconception around these. In large part, you know, I mean, we didn't really talk about this at the beginning, but there's an odd notion around APIs in part because of their longevity. We've been working with them for a long time, so people kind of assume we figured out security a long time ago, and it's really not the case. And I think WAFs and API gateways are a great extension of that. These providers need to essentially position their devices as, you know, a secure platform or answering your security problems. And they solve a piece of the problem, but they don't really protect against APIs. They weren't really designed to. API gateways, of course, are not first and foremost security devices at all, and WAFs were designed to solve a different problem. So what we're going to do here, guys, is play a video that's an attack playback. It was too hard to pull all these pieces together live, so we captured a recording of it and are going to show a series of attacks and how different devices work against them. So let's take a look at that now.
In this demonstration, we'll launch different kinds of application and API attacks and show how different protection platforms respond to the attacks. We'll use Postman to launch the attacks via API requests. The first attack is a traditional classic SQL injection, and we'll look how a traditional WAF, in this case Cloudflare, responds to the attack. First, let's look at the Cloudflare config. Basically, I have all the defaults. I click on Firewall, Managed Rules. I have the WAF turned on. I have the mod set core rule sets turned on, sensitivity to high, action is block. There's not much more I could enable on this. This is default out of the box. I didn't even set up any firewall rules for permit, deny. So let's launch our first attack. It's going to be, as I said, a classic SQL injection. We have one that puts an OR 1 = 1 here. We click send, and we get something back. And we learn that we've been blocked. The Cloudflare has blocked us. Okay, let's go see what happened in Cloudflare. If I click on overview, there's a log at the bottom. Looks like I have 24 attacks so far. Clicking the most recent one, I see a SQL injection that's been blocked, and here's my OR 1 = 1. Now let's launch a second set of attacks. In the second sequence, we'll launch about 30 different attacks, most of which are the kinds of API-based attacks we're hearing about so much these days. API attacks are different. There's no preset vulnerability or known bad for anything to leverage. Instead, attackers need to probe your APIs to learn the unique business logic of each API. The OWASP API top 10 list documents various types of attacks that are used by attackers as they manipulate the business logic. I have folders for each of those different attempts, those different types, and I will click run to create a collection. So here I've got about 30 of them that will execute all one right after the other. I'll click run and we'll get going. Okay, let's first look at the WAF. I have 24 events. If I hit refresh, let's see how many I have. Now I have 30 events in the WAF. It looks like the WAF has found 6 additional events. This time we will edit the columns and we'll look at path, the query string, and see what we have. So we see that the WAF has identified the OR 1 = 1 style attacks. There are probably some cross-site scripting in here as well that have been blocked. Yes, all of these are blocks. They're all either cross-site scripting or SQL injection. So we notice that we've got like 6 or 7 of these, and they're all like the first attack. They fit a known pattern. This type of attack was previously number 1 on the old OWASP list, but has been dropped to number 8 on the new API top 10 list. However, the WAF missed the other 23 attacks or so. These are the kinds of API attacks that we see today, where the attacker has to manipulate a bunch of API calls to see what's possible. So looking here at the SALT platform, I currently have 9 attackers with multiple attempts. That's one thing you get with big data, is the ability to correlate things together. I see that 16 days ago, there were 122 attempts by someone that had this authentication token. 25 days ago, 385 attempts by this particular IP address. So when I refresh this page, I see 2 more attackers. Both of them are from my Postman run. Some of those attacks, a token was used. In other attacks, it was not used. So I see the 2 of those there. If I click on one, I see various things, but the most important thing to note here is that I've got all the different types of attacks that were launched against this application. I've got a potential BOLA, I've got broken authentication, I've got several from the OWASP API top 10 category that were launched here that SALT was able to identify. So let's wrap up. We've seen that a WAF is able to identify an attack if the transaction contains a known bad pattern like SQL injection, cross-site scripting, but it could not identify any of the other API attacks. For these attacks, you need something that has context to understand how your API is unique and how it's normally used. SALT Security is able to identify not only injections, but more importantly, logic-based attacks. SALT leverages AI, ML, and big data to understand the unique behavior of every user across every element of every API.
All right, that's a really helpful example, and I think it makes it pretty clear how, the nature of these kinds of attacks is really different. But even within that, Michael, one thing that really struck me is what we saw happening there, what we've seen you showing us. This is a lot of brute force. This is a lot of kind of onesie, twosie, got to go figure out this API. How do attackers do that at scale?
Yep. Yeah, absolutely, Michelle. Yeah, and the video actually showed kind of, I'd say, a more traditional exploit with SQL injection attacks and cross-site scripting. Which, WAFs are, let's be honest, they're kind of built to detect that, but you saw in the video, they can't even catch them, unfortunately. Attackers, they may or may not use those types of exploits of the underlying code. More so what we're seeing these days are scraping attacks. Right? We've seen a lot of those very recently. You mentioned kind of the Peloton example, or exposing more information than it should. But credential stuffing is a really big problem, right? And it's we're going to talk about it, right? There's this big world of automated attacks, and really they're targeting the business logic of the APIs, which Sean talked about in that video. It's not something that a WAF can deal with, right? And the reality of an automated attack like credential stuffing or brute forcing is that your authentication and authorization mechanisms might be very strong. Like you might have done everything described by NIST or whatever regulatory body you're subject to. But maybe if you're doing every best practice, you still might experience credential stuffing. And actually, that's typically what we see with a lot of our SALT customers. Credential stuffing is very common, right? This one hits every industry. So let's kind of talk about that attack pattern specifically. But just remember, this is one of probably about I'd say conservatively 10 types of automated attack patterns, but there's much more, probably 20 or 30 conservatively. So what does a credential stuffing attack look like? We talked about reconnaissance at the start of this presentation, right? There's a large variety of ways an attacker does that. Typically, they're going to use the client app, like I showed you, like pick that apart, start reverse engineering the client-side code, look at what's actually going on at a code level, but how are the APIs communicating, right? And then I can start to craft API requests, and then I can likely script those and take the client app completely out of the picture. So once I've kind of found an appropriate target, the next step in credential stuffing is you need pilfered credentials, right? And these are plentiful, unfortunately, right? Because there's been so many data breaches and losses of credentials historically, and we know users myself included, right? We're busy. We use many different services. There's always a human tendency to reuse passwords. Certainly usernames, right? So if you can get a username, you got one piece of the puzzle. And passwords, a lot of sites restrict complexity or length. So it's really common to have common passwords. So attackers take these pilfered credentials from other data breaches over the past 10 years. Not hard to get a hold of. And then they're going to plug them into their automation tool of choice. That can be something like Burp Suite. We certainly see cases where attackers use those tools. You could use OWASP Zap. Many of those debugging tools have extensibility features, right? So you can start to create your own code and extend what the proxy is able to do. But in many cases, they're actually going to just write their own scripts, like Python code. We've seen that as well. Certainly in the case of the Parler attack, there were plentiful scripts all over GitHub that allowed you to kind of hit Parler's APIs and scrape all of the data. But if they're using an automation tool, it actually typically gives you throttling capabilities, which is important, right? Because typically when organizations use traditional approaches like API gateways or WAS, or kind of any network load balancer, maybe an application delivery controller, they're going to implement some type of rate limit, but they tend to be static, right? So attackers know this. They'll throttle their own connections to kind of fly under the radar of those rate limits, either for detection or for blocking, right? So it's kind of low and slow, right? You've probably heard that if you're in the world of security, but if you're not, it's essentially this, right? I want to fly under the radar. I want to make myself kind of transparent, blend into normal usage. So don't fire off 10,000 requests in a second. Maybe just do one every minute. And this is how it works, right? And it does occur over time. If you're kind of an inexperienced attacker, you might forget to do that, and then it might actually look like a denial of service event because you're sending too many requests. But typically credential stuffing is much more stealthy than that. The next step is really launch the attack against the login APIs in particular. So if you think about that burp screenshot I was showing where I was capturing the Google authentication API traffic, that might be the API I'm targeting specifically. And Burp Suite has a function to do this with Burp Repeater, but like I said, I could just as easily create some Python code to do that. Maybe it's going to call out to curl or HTTP Py to execute those HTTP requests to the login API endpoint. And then as an attacker, I just need to track, did that login credential work? If it did, awesome, because that means I now have a working credential. And ultimately, this is account takeover, right? And this is organizations that worry about credential stuffing and brute forcing, which is essentially everybody. Ultimately, the thing they're worried about is account takeover, right? And as an attacker, if I have a working credential, I now have achieved account takeover. The other way to do that is to hijack working sessions. But yeah, these are the tools of the trade for kind of achieving credential stuffing. Expanding on this a little bit, typically what happens, as attackers organize, maybe it's state-sponsored that they're doing this. We do commonly see that. They might use tools, like I said, they might use Burp. More likely they're going to use scripts. You have to remember, this isn't necessarily somebody with hands-on keyboard launching the attack. They've likely kind of pre-configured payloads, if you will, but it's all of the attack information they need and all of those scripts. It's all queued up, right? And they're going to distribute that likely worldwide, right? You can spin up instances in clouds. We see this very commonly. And cloud compute it's cheap to procure, right? That's kind of the appeal of it. Attackers know that too, right? And they also know that cloud service provider IP address space is typically allowed wholesale, right? Like you probably trust Amazon or Azure or Google. So if I could spin up a workload in that cloud, it might just pass right through all of your network access controls and traffic management functions. But yeah, attackers distribute their attacks, right? Once I've codified that thing, I figured out how the API call works. I don't care about the client, right? It kind of becomes throwaway. The API is the thing of value. Now I can script that, coordinate these attacks. I have working credentials. Now I can start to scrape data, right? Or maybe I'm going to pivot my attack. Maybe I'm going to escalate privileges. It kind of varies, right? But once you have working credentials in an app, that's kind of the keys in, right? Now I can start to do some more malicious things. So yeah, like I said, it's typically low and slow and highly distributed, and that's really to evade detection by essentially every kind of security mechanism we know today, because the attackers want to succeed, right? They get very frustrated if they're bumping into rate limits or rules on a WAF, right, or an IPS that's detecting them. So low and slow is the name of the game. Those controls are going to miss it.
Yeah, I think that's a crucial thing to understand is they know what is likely deployed in an environment. They know the protections that are likely in place. And if you think about some of these well-publicized breaches, bigger companies, I think there's a few things to think about. One is you can assume that, folks like Experian and Echelon and Peloton and, Facebook and Panera, they had all the traditional controls in place. It's not like they didn't have AppSec teams or have WAFs or gateways, and the thing still got through. I think that's important to keep in mind. I think another thing to keep in mind is who's where's the value? People will say, well, I don't think we're likely to be attacked because I don't think we're that interesting. The reality is there's a lot of sources of value. And sometimes just getting that cache of records that they can, sell on the dark web is attractive, could lead to other things. And so it may not be that you think you're attractive, but there still could be stuff in there that is attractive to an attacker. And I think the third dimension, and I think you're going to touch on that a little bit here in this next slide here, is that there's different kinds of forms of attack. There's attacks that are out and out like, oh, there was a problem in how this API was written, and I'm able to tap this misconfiguration and go do something. But then I also think, and you've touched on this, sometimes there's just an abuse of an API. It's acting as it was designed. It's doing what it was supposed to do. This is, the Experian one, where somebody was able to look up credit scores of any individual using publicly available information about people. The API worked as designed. They just didn't anticipate the abuse of that API for somebody to go pull credit scores for a bunch of people at random. And so I think what will be helpful here, Michael, is for us to understand, what are the things, like the onus is on us to wake up and to understand what's going on, and to understand that there could be repercussions to us as a business, even if it's just a privacy issue versus a true hack. And, just getting ahead of that kind of thing. I think this will be really helpful for people to try to prepare.
Yeah, absolutely. Yeah, and I like the Experian example too, because it's the reality of building APIs for different business cases, right? Because I have to imagine Experian was somewhat aware of the risk of having an API that was using weak authentication factors. But for their business model, they felt that was necessary, right? Because they were trying to facilitate lending, right, by working with partners. So, I mean, that API, it's not a black box, right? We've talked about that. It is exposed. Somebody's going to find it. But, once it's uncovered, and there's kind of this trade-off, right? Like, well, I need to do business. I have to enable a business. I can't turn on every authentication factor. I can't use second factor authentication. I can't use OAuth, right? Because I haven't, like in the Experian case, this isn't even a customer yet, right? Like I am trying to bring them in. They're not going to be a registered user. So what do I challenge them with, right? So that's reality, that's business reality, right? And as a security practitioner, there's that tendency to be like, well, why'd they do that? That was so stupid. They should use 2FA. They should have asked for, 10 more pieces of authentication information. And then why'd they return all this data? That was the business model. But it's exactly what you said, Michelle, right? They didn't necessarily think about the abuse of that API, or, how somebody might extract that data. In that case, I don't think it was enumerated at scale, right? They didn't, the researcher just kind of pointed it out for themselves. But it wasn't like Parler, right, where they kind of, well, we got millions of users' data. That could have been what happened, right? And it had credit qualifying information and FICO scores. That's a PR nightmare. It's not necessarily an attack either, right? Like Experian might not have even considered that a breach. But these are kind of the incidents that, saying that.
Exactly. This is what we're seeing today, and your setup to all of this is so valuable in that security is always a business decision. It is a risk trade-off decision. You could be infinitely secure, but you probably don't have enough money, you probably don't have enough manpower, and you've probably thwarted the business in the process. So that's not going to work. So you got to find the balance point. I think what's important to understand is that there can be a risk for miscalculating that risk because you don't really understand how attractive APIs are, or how easy they are to get into, or how easy they are to understand. I mean, it's not super easy. It takes some time and energy, but it's far from impossible. And I think what you're advocating for here is understand better what's going on so that you are more accurately assessing risk.
Yep. Yeah, you have to understand those consumption patterns, right? Because yes, there might be things like SQL injections, but it's much more than that, right? Like, and to try to grasp, like, what are all the possible ways somebody might abuse my API? Not necessarily something like we as practitioners can even grasp, right? That's kind of why we need machines to help us unearth, well, this is the normal, right? This is anomalous. You have to keep an eye on those baselines and track things over time, right? So it's the context, not one particular transaction. So yeah, common vernacular is entirely lacking, right? Time and time again, I would advise organizations about OWASP. It's a great resource. Not everybody's familiar with the API Security Top 10, unfortunately. It is newer. It was released in 2019. Hopefully be going through a refresh this year. But it's only 10 issues, right? They are very critical. Number 1 and number 2 are authentication and authorization problems. But it's tip of the iceberg, right? And sometimes those definitions are overloaded. I think credential stuffing is mentioned very briefly, or brute forcing within one of those first 2. But as you saw, it's very unique. Right? It wouldn't be fair to say somebody's authentication is broken if they're doing everything, right? And an attacker just came in, pilfered a credential, and reused it, right? Like, how are you supposed to combat that? So some of those things are a little evolving, right? But it's also kind of the nature of the beast, right? You're trying to take 10 issues and give people advice on how to act on them. I mentioned how credential stuffing can look like a denial of service event. We've seen this with customers where they kind of shift, right? They're like, well, this looks like a DDoS, right? And they're panicking because it's incident response. And then next they're saying it's brute forcing. And then as you dig in, you realize it was actually credential stuffing, right? But ultimately it's to achieve account takeover. And then the leaky APIs, what does that mean for an API to be leaky? That's, typically weaker authentication, but it's exposing sensitive or private user information that you just don't want to divulge. The attackers are learning faster than practitioners. I showed how attackers distribute their attacks, right? They're going to spin up workloads in cloud. They can do that with very minimal budget, right? They don't need to be a state-sponsored attacker to do that. That causes a problem for a lot of organizations, kind of network monitoring, right? Because now you're shifting through all these IP address spaces. How do you correlate all that? I showed how they throttle, right? It's very easy. Most tools give you the ability to throttle. And most organizations are going to implement somewhat relaxed rate limits because they don't want to impact user experience, right? If you're too aggressive with that, rate limits on your API, it's actually going to impact legitimate users or your partners. And we've talked about this kind of throughout, But the traditional security approaches are failing organizations, right? They are there. They help protect certain types of applications, like WAFs can work for general web applications. But as soon as you get into the world of custom application design, and certainly APIs, very limited value, right? And an API gateway, first and foremost, is essentially access control mechanism, typically paired with your identity and access management, so they become enforcers of your access control policies. Some of the better gateways might give you threat protection filters, but they're essentially WAFs, or the rules that you might expect to find in WAFs, just even more generic, right? So not very high value. And as we talked about, most API attacks are actually business logic attacks. And, these sets of tooling just aren't built for that. It's just kind of the reality.
Yeah, our CEO makes an analogy that WAFs kind of look at the world. It's like watching a video one frame at a time. You're never going to get the movie. And with APIs, you need the movie because any given single transaction in isolation may not trigger any kind of response, but you need that notion of context over time to to really understand the big picture.
Yeah, and I love that video that Sean put together, with the Cloudflare console. But it's not just Cloudflare, right? It's every WAF. You're likely staring down, tens of thousands of events where somebody might try to script a very basic exploit attack. They might even just fire off a scanner, and it just creates a lot of noise, right? Like you don't even know, like, is that a legitimate user? Like, what's going on? So yeah, they give you very limited context. It's a big problem with WAFs. It's like, how do you operationalize these things? A lot of times organizations are just shifting off them, right? They'll kind of go with lowest common denominator, maybe even a fully managed service, because they're tired of maintaining the rule sets. It just doesn't do anything for their modern tech stack.
Yeah, not enough value for the work.
Yep. So really quickly, let's kind of talk through what do we do at Salt Security in our API protection platform. Very quickly, we kind of acknowledge the realities of modern architecture, and that's you're likely building many things, right? You have your monoliths, you have your microservices, you have legacy architecture, you have cloud environments. Everybody's somewhere in that curve, and maybe you'll stay there, right? Like you might keep monoliths. There's legitimate business reasons to do that. But your APIs are going to exist everywhere, right? And they're generating traffic. So you have to have kind of this complete visibility of all of the traffic. With all that traffic, there's a lot of signals, right? And I talked about we as practitioners, you really can't keep sight of everything, right? Like how do you know what normal is? Typically that would be a collection of, app dev, infrastructure, security teams, network engineering. And if you have all those teams, does that person know that particular app and its entire tech stack? Usually the answer is no, right? So you need machine learning and AI to kind of piece together all this information and correlate it. It has to be backed by cloud storage, aka big data, right? Because there's just a lot of data. You're never going to be able to keep all of this in your data center or even a private cloud segment. It has to be elastic to keep track of all of that data. Collectively, we call this C3A, the context-based API analysis architecture. That feeds our platform. And the capabilities of the platform, essentially sums up to three high-level categories, but that is, discover all of your APIs and where sensitive data, including PII and maybe those pieces of private data like you saw with Peloton or Experian. Stop the wide range of attacks, including OAuth's top 10, but going beyond that, like the automated attacks we were talking about with credential stuffing. And then also help improve your API security posture, right? So in the beginning, I talked about my experience with DevOps and DevSecOps. Typically organizations want to empower everybody in the enterprise. So development teams need insight into security. They're not versed in that, right? So you need tooling that kind of gives them actionable advice. And security teams are tasked with finding the right tooling that can translate to developer language. So that's another capability of the platform, right? As we're monitoring your APIs and finding weaknesses, we're kind of spelling that out for development teams in the organization on how they might address it. Or, maybe it needs to be something you handle in infrastructure as a rate limit because you're seeing a very specific type of attack pattern emerge. So yeah, I kind of talked through these as I went through the build, but it's, I'd encourage you to certainly go to our website. We have a lot of information on this, a lot of videos. If you want a technical demo, we can certainly arrange that. But yeah, these are kind of the key takeaways. Another big one is, we don't deploy proxies. We integrate with your proxies, right? Because your enterprise architecture is likely overloaded with them already, right? Proxy overload is something I heard commonly as an analyst, as I was, looking through every organization's enterprise architecture and trying to advise them, well, this is how you might implement a WAF or an API security offering, or an API gateway, right? If you wanted to mediate API calls. But there's a lot of proxies, right? Sometimes too many. There's likely a cloud CDN as well. That's yet another set of proxies. Every time you add a proxy, it's a potential failure point, but it also complicates like encrypted communications like TLS and troubleshooting, right? And it can add latency to your app performance. So it's not how we've designed the platform.
Awesome. Great wrap up. So, just stepping back, so what do we understand, right? Hackers have the motivation, they have the tools, and they have the patience, right? Because this is so worth their time. The payoff can be so huge. APIs are a direct route straight to your most critical data and services, and hackers understand that, and they're coming after it. And companies, for the most part, are pretty hugely exposed here. Existing protections really just don't work against the nature of API attacks, and I think it's important that companies are kind of eyes wide open about what's happening on this front. So Michael talked through, how we work. One other thing, we have an offer for an API gap analysis. So we can do a no-cost assessment for you to understand what's happening in your environment. So we'd love to just show you what's going on and show you what's happening in your application space. So with that, I think we'll wrap up. Michael, thank you so much for taking us through how this all works.
Yeah,
what the tools
I wish I had more.
Like.
Yeah, I was like, I could fire up Burp. Just give me another hour. I'll show this live. But yeah,
right, exactly. So. It's unfortunately easier than any of us want to think about. So, all right, with that, thanks so much for joining us today. We hope you have a wonderful day, and thanks for your time.
Thanks, everybody.